Friends, today in this video we are going to discuss about the differentiability of a function at a point. For this, let us say if be a real valued function defined on an open interval ab. Let C be any point in between a and b. That means a is less than c is less than b. Then f is said to be differentiable at c if and only if limit x approaches to c of f of x minus f of c upon x minus c exist finitely. That is, this limit exists and it is a finite number. This limit is called as derivative or differential coefficient of f at x equals to c, and it is denoted by f dash c or df at c or d by dx of f of x at c. Thus, derivative of function at c is given by the limiting value of f of x minus f of c upon x minus c. Now, we know that limit x approaches to c of f of x minus f of c upon x minus c exists if and only if limit x approaches to c negative of f of x minus f of c upon x minus c is equal to x approaches to c plus of f of x minus f of c upon x minus c. That means the limit of a function exists if the left hand limit is equal to right hand limit. So that is why this limit will exist if the left hand limit about c is equal to right hand limit about c. So suppose h is a very small number, then limit h approaches to 0 of f of c minus h, because if we have a point c on a real line, then those numbers which are on the left of c, they are of the kind c minus h, and those which are on the right of c, they are of the kind c plus h. So we have for calculating the left hand limit of this expression, we have to replace x by c minus h, where h is tending towards 0, of f of minus f of c upon c minus h minus c is equal to limit h goes to 0 f of c plus h minus f of c upon c plus h minus c. As you can see, the c will cancel in the denominator. So this expression becomes limit h goes to 0 of f of c minus h minus f of c upon minus h is equal to limit h goes to 0 of f of c plus h minus f of c upon h. This quantity is called as left hand derivative, and this quantity is called as right hand derivative. That means a function is differentiable. A function f is differentiable at c if left hand derivative at c is equal to right hand derivative at c. And we represent this by L f dash c is equal to R f dash c. That means a function is differentiable if left hand derivative is equal to right hand derivative. So if you again look at the expression, this limit exists if limit h approaches to 0 of f of c minus h minus fc upon minus h is equal to f of c plus h minus fc upon h. Now geometrically, consider a function. Consider a function f of x defined on an open interval ab. Let P with coordinate C, FC be a point on the curve y is equal to f of x, and let Q with coordinates c minus h and f of c minus h, and another point R, c plus h and f of c plus h, be two neighboring points on the left hand side and right hand side of P respectively as shown in figure. Now you can see the figure. This is point P with coordinates c and f of c, and R is in the right neighborhood of P with coordinates c plus h and f of c plus h, and Q is a point in the left neighborhood of P with coordinates c minus h and f of c minus h. Then slope of slope of QP will be equal to f of c minus h minus f of c upon c minus h minus c, which equals to f of c minus h minus f of c upon minus h. As this Q will move nearer to P, then this H will tend towards 0. So this equals to limit H goes to 0, f of C minus H minus f of C upon minus H. What happens when Q is approaching 0? Then H is tending towards 0. So this chord QP will become slope of tangent at P when Q approaches P. So that means Q approaches P. This is f of C minus H minus f of C upon minus H. Similarly, if you look at this chord PR, the slope of PR will be equal to slope of chord PR. This will be equal to f of C plus H minus f of C upon C plus H minus C, which equals to f of C plus H minus f of C upon H. As this R approaches to P, when R will come closer towards P, this H will become smaller and smaller and it will tend to 0. So in that case, it becomes slope of tangent at P as R approaches to P. So this will be equal to limiting H approaches to 0, f of C plus H minus f of C upon H. Now, if this function is differentiable at point C, then this limiting value is equal to this limiting value will be equal to this limiting value. So that means limit h approaches to 0, f of c minus h minus f of c upon minus h is equal to limit h goes to 0 of f of c plus h minus f of c upon h, which means the slope of tangent at p when q is approaching p is equal to slope of tangent at p when r is approaching p. So geometrically f dash c represents slope of tangent at P, it is and it is unique. So whenever we are finding the derivative at a given point, it represents the slope of tangent to that curve at that point, and it is a unique tangent. So whenever we find the derivative, it means we are finding out the slope of tangent at the particular point. Now, moving towards an important result. every differentiable function is continuous, which can also be remembered as differentiability implies continuity. So for this, we are assuming let f be a real valued function on an open interval AB. Let f is differentiable at C belonging to AB. That means this function is differentiable at point C. If this function is differentiable at point C, then f dash C will be equal to limit x approaches to C of f of x minus f of C upon x minus C. Now what we need to do, if this function is differentiable, we need to show that this function is continuous. And we know that a function is continuous if you remember the continuity chapter, a function is continuous if limit x approaches to C of f of x exists and limit x approaches to C of f of x is equal to f of. And we are discussing a theorem. Every differentiable function is continuous. That is, differentiability implies continuity. For this, what we have taken, let f be a real valued function defined on an open interval AB. Let f is differentiable at x equals to c belonging to A. As we have done earlier, a function is differentiable at a point if the limit, that is, that is, f dash c is equal to limit x approaches to c of f of x minus f of c upon x minus c exist, and that limit is called as the derivative of function. So if this function is differentiable at c, that means f dash c is equal to the limiting value of fx minus fc upon x minus c. Now we need to show that this function is continuous at c. If you remember the definition of continuity, there we have defined that a function is continuous if is continuous at x equals to c if limit x approaches to c of f of x is equal to f of c if this limit exists finitely. So we shall prove using this concept that this function is also continuous. So for that, consider f of x minus f of c This will be equal to f of x minus f of c upon x minus c into x minus c. हमने क्या किया यहाँ पर? हमने f x minus f c कंसिडर किया, x minus c से मल्टीप्लाई किया और x minus c से डिवाइड किया. Now limit x approaches to c of f of x minus f of c will be equal to limit x approaches to c of f of x minus f of c upon x minus c into x minus c. So this equals to limit x approaches to c of fx minus fc upon x minus c into limit x approaches to c of x minus c. अभी भी हमने बात किया कि fx minus fc upon x minus c x approaches to c is f dash c. तो इस लिमिटिंग वैल्यू की जगह पर I can use f dash c. अब ये 0/0 फॉर्म नहीं है तो हम x को रिप्लेस कर सकते हैं c से. c माइनस c किसके इक्वल हो जाएगा? 0 के इक्वल. दैट मीन्स लिमिट x approaches to c of fx minus fc is equal to 0. Since ये टर्म जो है x से इंडिपेंडेंट है तो I can write this expression as x approaches to c of fx is equal to f of c, which shows that f is continuous at x equals to c. Hence, f is differentiable implies f is continuous. That means जो फंक्शन डिफरेंशिएबल होता है किसी पॉइंट पे, उस पॉइंट पे वो कंटिन्यूस भी होता है, बट इसका कन्वर्स जो वो ट्रू नहीं होता. तो उसके लिए मैं एक एग्जांपल ले रहा हूँ. शो दैट a continuous function need not be differentiable. हर डिफरेंशिएबल फंक्शन कंटिन्यूस होता है लेकिन हर कंटिन्यूस फंक्शन जो होता है वो डिफरेंशिएबल नहीं होता. अब यहाँ पर मैंने इसका कन्वर्स की बात किया. कंटिन्यूस फंक्शन डिफरेंशिएबल हो भी सकता है, नहीं भी हो सकता है. तो हमें यहाँ पर क्वेश्चन क्या है, हमें एक एग्जांपल देना है, शो दैट अ कंटिन्यूस फंक्शन नीड नॉट बी अ डिफरेंशिएबल फंक्शन. So for that, I'm assuming f of x equals to mod of x, and we know that mod of x is equal to x. This is equal to x when x is greater than or equal to 0 and minus x when x is less than 0. Now I can show that this function is continuous at 0. So for that, limit x approaches to 0 negative of f of x. This will be equal to limit x approaches to 0 when x is less than 0. F of x is minus x. Since it is not 0/0 form, so I can replace x by 0 equals to 0. Similarly, limit x approaches to 0 plus of f of x. This will be equal to limit x approaches to 0 of x, which is equal to 0. And f of 0 is equal to modulus of 0, which equals to 0. That is limit x approaches to 0 negative of f of x equals to limit x approaches to 0 plus of f of x is equal to f of 0, implies f is continuous at x equals to 0. Now, let's check the differentiability of this function at 0. So for that, we are calculating the left hand derivative at 0. और अगर आप याद करें तो मैंने आपको लेफ्ट हैंड डेरिवेटिव का डेफिनेशन दिया था. लिमिट h goes to 0 f of 0 minus h minus f of 0 upon minus h, जो किसके इक्वल हो जाएगा? लिमिट h goes to 0 of modulus of minus h minus mod of 0 upon minus h, which is equal to limit h goes to 0, h minus 0 upon minus h, which simplifies to minus 1. इसी तरह से right hand derivative at 0. Let's do it again. F of x is equal to mod of x. We are going to prove that this function is continuous at 0. For that, limit x approaches to 0 negative of f of x is equal to limit h goes to 0 of f of 0 minus h, which is equal to limit h goes to 0 of modulus of minus h, which is equal to limit h goes to 0 of h, which equals to 0. Similarly, limit x goes to 0 plus of f of x will be equal to limit h goes to 0 of f of 0 plus h, which is equal to limit h goes to 0 of mod of h, which is equal to limit h goes to 0 of h equals to 0. And f of 0 is equal to mod of 0 equals to 0. That is, that is, limit x approaches to 0 negative of f of x is equal to limit x goes to 0 plus of f of x equals to f of 0 implies f is continuous at x equals to 0. Let's check out whether this function is differentiable at 0 or not. For that, we're calculating the left hand derivative at 0, which is equal to limit h goes to 0 of f of 0 minus h minus f of 0 upon minus h. ये किसके इक्वल आ जाएगा? This equals to limit h goes to 0 mod of minus h minus mod of 0 upon minus h is equal to limit h goes to 0 of h minus 0 upon minus h. Simplify, okay, this equals to minus 1. Then right hand derivative at 0. By definition, this is h goes to 0 f of 0 plus h minus f of 0 upon h, which is equal to limit h goes to 0 mod of h minus modulus of 0 upon h, which equals to limit h goes to 0 h minus 0 upon h, which equals to 1. Left hand derivative हमारे पास क्या आया था? -1. Right hand derivative +1. That means they are not equal, which implies f is not differentiable at x equals to 0. Earlier we have proved that it is continuous, but here we are showing that it is not differentiable at 0. That means every continuous function need not be differentiable. Means हर continuous function differentiable नहीं होता. कुछ continuous function differentiable हो भी सकते हैं, लेकिन कुछ functions differentiable नहीं भी हो सकते. लेकिन every differentiable function is continuous, वो हम already theorem prove कर चुके हैं अभी. Every differentiable function is a continuous function. तो ये दो important results हैं which we will use in Rolle's theorem and mean value theorem in the later on and the later stages of this chapter. So let's take some certain more examples to check the differentiability of the functions. How we can prove that a function is differentiable or a non-differentiable? That we have seen that a function is differentiable if left hand derivative is equal to right hand derivative, and if two are equal, then that function is differentiable. So let's take another question. Prove that function f given by f of x equals to modulus of x minus 1 for every x belongs to R is not differentiable at x equals to 1. Proof: f of x is given equal to modulus of x minus 1. With the help of this, what is f of 1? हमने x की जगह पर 1 लिखा, तो right hand side पे भी it will be 1 minus 1 which equals to. Now let's calculate the left hand derivative at 1. Left hand derivative at 1 will be equal to limit h goes to 0 more f of 1 minus h minus f of 1 upon minus h. H is very small quantity that is taken as tending towards 0. Limit h goes to 0, modulus of 1 minus h minus f of 1 is 0 upon minus h. So what we have, instead of x we are having 1 minus h, and the definition of f was f of x is equal to x minus 1. So x की जगह पर हमने 1 minus h पुट किया, x की जगह पर हमने 1 minus h पुट किया और minus 1 जो वहां पर दिया हुआ, ये 1 और ये 1 कैंसिल हो जाएगा, हमारे पास क्या आ जाएगा, लिमिट h goes to 0 of modulus of minus h upon minus h, which is equal to limit h goes to 0 of h upon minus h. Again h और h cancel, so this equals to minus 1. इसी तरह से we'll calculate the right hand derivative at 1, which is equal to limit h goes to 0 of f of 1 plus h minus f of 1 upon h, which is equal to limit h goes to 0 modulus of 1 plus h minus 1, again x की जगह पर 1 plus h minus f of 1 is 0 upon h. This simplifies to limit h goes to 0 modulus of h upon h, which is equal to limit h goes to 0 h upon h, because h is a positive number tending towards 0. This simplifies to 1. Left hand derivative minus 1, right hand derivative 1 means they are not equal. Clearly, left hand derivative at 1 is not equal to right hand derivative at 1. Hence, f of x equals to modulus of x minus 1 is not differentiable at x equals to 1. Okay. Now, let's take another question. Prove that greatest integer function defined by f of x equals to greatest integer value of x for every x belongs to real numbers is not differentiable at x equals to 2. Proof: we are given that f of x is equal to greatest integer value of x for every x belongs to R. Let H belongs to R be a very, very small positive number. It is as small as possible. That means it can be approximated as 0. Then 2 minus H will be a number less than 2, and it will be greater than 1 because H is very, very small, that is negligible. And 2 is less than 2 plus H is less than 3, because if H is very small positive number, when it is subtracted from 2, then it will be lesser than 2, and when it is added to 2, it will be greater than 2. Now we need to show that this function is not differentiable at 2. For this, left hand derivative at 2 by definition is equal to limit h goes to 0 of f of 2 minus h minus f of 2 upon minus h. ठीक है, which equals to limit h goes to 0, 2 minus h का greatest integer value minus greatest integer value of 2 upon minus h. As you can see, 2 minus h is number between 1 and 2, और greatest integer number क्या करता है, उस नंबर को अपने predecessor integer पे मैप करता है, जो भी उसके नेबरिंग में हमारे पास इंटीजर होता है ऑन द लेफ्ट साइड. तो 2 माइनस एच कहां पर मैप हो जाएगा, 1 पर, माइनस ग्रेटेस्ट इंटीजर वैल्यू ऑफ 2, 2 बीइंग इंटीजर तो इसकी ग्रेटेस्ट इंटीजर वैल्यू क्या रहेगी, 2 अपॉन माइनस एच. तो ये किसके इक्वल हो जाएगा, लिमिट एच गोज टू 0 minus 1 upon minus h, minus and minus cancelled out. So this equals to infinity, because when h will approach to 0, 1 by h will approach to infinity. Now let's find right hand derivative. This will be equal to limit h goes to 0, f of 2 plus h minus f of 2 upon h, which is equal to limit h goes to 0, greatest integer value of 2 plus h minus greatest integer value of 2 upon h. Now, as discussed earlier, 2 plus h is number greater than 2. So, greatest integer value of 2 plus h किसके इक्वल हो जाएगा, 2 के इक्वल, minus greatest integer value of 2 is 2 upon h, which is equal to limit h goes to 0, 0 upon h, 0 upon h is 0. Left hand limit was infinity, right hand limit is 0. That means left hand derivative at 2 is not equal to right hand derivative at 2. Hence, f of x equals to greatest integer value of x is not differentiable at x equals to 2. Now, let's take another question. Show that the function f of x given by 12x minus 13 when x is less than equal to 3, and 2x square plus 5 when x is greater than 3 is differentiable at x equals to 3. Proof: we are given that f of x is equal to 12x minus 13 when x is less than or equal to 3, and 2x square plus 5 when x is greater than 3. और हमें ये बताना है कि ये फंक्शन जो है 3 पे डिफरेंशिएबल है. कोई भी फंक्शन डिफरेंशिएबल होता है किसी भी पॉइंट पे जब लेफ्ट हैंड डेरिवेटिव और राइट हैंड डेरिवेटिव इक्वल हो. तो हम कैलकुलेट करेंगे लेफ्ट हैंड डेरिवेटिव एट 3, which equals to limit x approaches to 3 negative of f of x minus f of 3 upon x minus 3. जैसा कि मैंने कंटिन्यूटी के टाइम पे आपको बताया था, जब भी हमारे पास लेस देन और ग्रेटर देन साइन हो तो वी डोंट इंट्रोड्यूस एच, हम डायरेक्टली लेस देन से लेफ्ट और ग्रेटर देन से राइट हैंड लिमिट्स इवैल्यूएट कर सकते हैं। तो ये किसके इक्वल हो जाएगा? लिमिट x अप्रोचेस टू 3, 3 नेगेटिव मींस लेस देन 3, और लेस देन 3 पे हमारे पास डेफिनेशन क्या है? 12x माइनस माइनस एफ ऑफ 3 इक्वल टू पे भी यही है, तो ये क्या आ जाए? 12 इंटू 3 माइनस 13 होल डिवाइडेड बाय x माइनस 3, इसकी इक्वल आ गया ये। लिमिट x अप्रोचेस टू 3, 12x माइनस 13, 12 3 ज़ा 36, 36 में से 13 चले गए 23 अपॉन x minus 3, which is equal to limit x goes to 3, 12x minus 36 upon x minus 3. अगर आप ऐसा नहीं करना चाहते हो, there is another way. देखिएगा ध्यान से, because I'm getting here, तो उसको हम अप्लाई कर सकते हैं। 12x minus 13, अगर इस ब्रैकेट को मैं डायरेक्टली ओपन कर दूं तो प्लस इंटू माइनस 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 इंटू माइनस प्लस 13 अपॉन x माइनस 3। चाहे आप ऐसा करें या जैसे पहले मैंने किया था वैसे करें, दोनों से आंसर आपका सेम आएगा। 13 और 13 कैंसिल। अब 12x माइनस 36, तो 12 इज अ कॉमन फैक्टर, तो हमारे पास क्या बना? लिमिट x अप्रोचेस टू 3, 12 टाइम्स x माइनस 3 अपॉन x माइनस 3, और ये x माइनस 3 कैंसिल, और x माइनस 3 कैंसिल होते ही 0 बाय 0 फॉर्म खत्म। जो हमारे पास रिजल्टिंग नंबर दैट इज इंडिपेंडेंट ऑफ x, सो इट इज 12। नाउ राइट हैंड डेरिवेटिव एट 3, this is equal to limit x approaches to 3 plus of f of x minus f of 3 upon x minus 3, which equals to limit x approaches to 3, 3 plus means greater than 3, और greater than 3 पे हमारे को क्या definition दिया हुआ है? 2x square plus 5, और f of 3 किसके इक्वल हो जाएगा? 12 into 3 minus 13 upon x minus 3, which equals to limit x approaches to 3, 2x square plus 5, 36 minus 13 is 23 upon, which is equal to limit x approaches to 3, 2x square minus 18 upon x minus 3, which is equal to limit x approaches to 3, 2 common x square minus 9 upon x minus 3, which is equal to limit x approaches to 3, 2 times x minus 3 into x plus 3 upon x minus 3, and this x minus 3 and x minus 3 cancel. Resulting expression is not in 0 by 0 form, तो हम x को replace कर सकते 3 से, which is equal to 12. Left hand derivative 12, right hand derivative 12, since left hand derivative at 3 is equal to right hand derivative at 3, hence f is differentiable at x equals to 3. Now let's take one more interesting problem. Find the value of a and b if the function f of x equals to x square plus 3x plus a when x is less than equal to 1, and bx plus 2 when x is greater than 1 is a differentiable function for every x belongs to R. Now we are given that this function is differentiable and we have to find the value of a as well as b. Let's calculate. Given f of x is equal to x square plus 3x plus a when x is less than equal to 1 and bx plus 2 when x is greater than 1 is differentiable for every x belongs to R. अगर ये सभी रियल नंबर्स के लिए डिफरेंशिएबल है, this means f is differentiable at x equals to 1, क्योंकि सभी पॉइंट्स पे डिफरेंशिएबल है. हमने 1 ही क्यों चूज किया? क्योंकि इस फंक्शन की डेफिनेशन जो है चेंज हो रही है 1 पे. 1 के लेफ्ट साइड पे it is x square plus 3x plus a. On the right of 1 it is bx plus 2. So we are taking its differentiability at 1. If this function is differentiable at 1, this means left hand derivative at 1 is equal to right hand derivative at 1, which means limit x approaches to 1 negative of f of x minus f of 1 upon x minus 1 is equal to limit x goes to 1 plus of f of x minus f of 1 upon x minus 1. ठीक है, क्योंकि फंक्शन डिफरेंशिएबल होता है तो मींस कि उसका लेफ्ट हैंड डेरिवेटिव और राइट हैंड डेरिवेटिव सेम है. सो दिस मींस लिमिट x approaches to 1 less than 1 पे definition was x square plus 3x plus a minus 1 पे भी it was same, that is 1 square plus 3 into 1 plus a upon x minus 1, which is equal to limit x approaches to 1 when x is greater than 1 it was bx plus 2 minus 1 square plus 3 into 1 plus a upon x minus, which gives you limit x approaches to 1 x square as it is 3x as it is a as it is 1 का square is 1 minus 3 minus a upon x minus 1 is equal to limit x approaches to 1 bx plus 2 minus 1 minus 3 minus a upon x minus 1. On left hand side a and a will get cancelled, so what we have, limit x approaches to 1 x square plus 3x minus 4 upon x minus 1 is equal to limit x goes to 1 bx 2 minus 4 is minus 2 minus a upon x minus 1. Now if you put x equals to 1 1 plus 3 4 minus 4 that is 0 by 0 form, तो हम इसको फैक्टराइज कर सकते हैं. This is limit x approaches to 1 x square plus 4x minus x minus 4 upon x minus 1, which is equal to limit x approaches to 1 bx minus a minus 2 upon x minus 1. This gives you limit x approaches to 1 then x plus 4 minus 1 into x plus 4 upon x minus 1 is equal to limit x approaches to 1 bx minus a minus 2 upon x minus 1. Then this becomes limit x approaches to 1 x plus 4 into x minus 1 upon x minus 1 is equal to limit x goes to 1 b x minus a minus 2 upon x minus 1. So x minus 1 and x minus 1 cancelled out. X को 1 put किया तो this will give you limit x goes to 1 of bx minus a minus 2 upon x minus 1 is equal to 5. अब आगे कैसे चले? This is a question. हमें तो a और b का वैल्यू फाइंड करना था. अगर मैं यहाँ पर 1 पुट भी कर देता, this is something upon 0. A not defined number cannot be equal to 5. So what we will do, we will make use of the concept. Which one? Differentiability implies continuity. अब देखिए यहाँ पर क्वेश्चन में हमें क्या दिया हुआ था कि हमें a और b का वैल्यू निकालना है, और जब दो अननोन्स हैं तो हमें दो कंडीशन दिए जाने चाहिए थे, बट कंडीशन एक ही दी हुई थी. दिस वाज अ ट्विस्ट इन दिस क्वेश्चन, बिकॉज इफ जितने अननोन्स होते उतनी ही कंडीशंस हो तभी हम उनको फाइंड कर सकते हैं. टू अननोन्स वर देयर, कंडीशन वाज ओनली वन डिफरेंशिएबल. So this was a hidden part where we have to use the concept of continuity also, since differentiability implies continuity. Therefore f is continuous at x equals to 1. If f is continuous at x equals to 1, this means limit x approaches to 1 negative of f of x is equal to limit x goes to 1 plus of f of x is equal to f of 1. And less than 1 पे definition was x square plus 3x plus a. 1 पे भी यही, तो लेफ्ट हैंड लिमिट और इमेज सेम आएंगे. ठीक है, तो हम लोग क्या कर रहे हैं, वी आर कंपेयरिंग राइट हैंड लिमिट विद द इमेज. दैट इज limit x goes to 1 plus of f of x is equal to f of 1. And what was f of x when x is greater than 1? It was bx plus 2 is equal to 1 square plus 3 into 1 plus a, which gives you, since it is not 0 by 0 form, I can replace x by 1 plus 2 is equal to 4 plus a, which gives you b is equal to 4 plus a minus 2, which is equal to a plus 2. If we put this value in first, where it was, अगर यहाँ पर हम सब्स्टिट्यूट करते हैं तो मेरे पास क्या आ जाएगा, that gives you limit x approaches to 1 of bx, b किसके इक्वल है, a plus 2 into x minus a minus 2 upon x minus 1 is equal to 5. अब a plus 2 हम कॉमन ले सकते हैं, लिमिट x goes to 1, a plus 2 कॉमन लिया तो ब्रैकेट में आ जाएगा x minus 1 upon x minus 1 is equal to 5. X minus 1 cancelled out, so you have a plus 2 is equal to 5, which gives you a is equal to 3. If a is equal to 3, then b is equal to a plus 2, which is equal to 3 plus 2 is equal to 5. Hence a is equal to 3 and b is equal to 5. This is the desired answer. एक बार फिर से चेक कीजिए. ये फंक्शन आपको डिफरेंशिएबल दिया था 1 पे. अगर ये डिफरेंशिएबल है तो लेफ्ट हैंड डेरिवेटिव इज इक्वल टू राइट हैंड डेरिवेटिव. उसमें हमने लेस देन 1 पे फंक्शन की डेफिनेशन पुट किया, एफ ऑफ 1 पे भी सेम था तो उसको सिंप्लीफाई किया. इसी तरह से ग्रेटर देन 1 पे इट वाज bx प्लस 2 सब्स्टिट्यूट किया, सिंप्लीफाई करा, तो वापस सिंप्लीफाई करते करते वी रीच टू दिस स्टेप. यहाँ पर ए और बी इन्वॉल्व है, तो राइट हैंड साइड पे अगर देखें तो वी आर हैविंग ए फाइनाइट नंबर, अगर 1 पुट करते दिस बिकम्स इनफाइनाइट, which is not possible. That means there is something hidden in it. So for that we are making use of differentiability implies continuity. So if every differentiable function is continuous, that means this the given function is also continuous. So it is continuous at x equals to 1. If it is continuous, then left hand limit at 1 is equal to right hand limit at 1 is equal to f of 1. So we are comparing right hand limit and image, which gives us a relation between a and b. Whatsoever we get the relation between a and b, we are substituting that value in equation first, where it was here. Instead of b, we are putting a plus 2, and then we're getting a plus 2 into x minus a plus 2. अगर इन दोनों में से माइनस कॉमन ले लें तो मेरे पास ये आ जाएगा. अब a plus 2 कॉमन लिया तो x minus 1 और x minus 1 कैंसिल, जिससे हमारे पास a की वैल्यू आ गई, b की वैल्यू आ गई. सपोज यही क्वेश्चन आपको एक नंबर का आता है तो थोड़ा सा मिनिमाइज कर रहा हूँ. सपोज दिस क्वेश्चन इज फॉर 1 मार्क, इट इज डिफरेंशिएबल फंक्शन. तो मेरे पास क्या आ गया, f of x मेरे को दिया हो तो f dash x will be equal to 2x plus 3, a का डेरिवेटिव 0 is equal to b, because bx की डिफरेंशिएशन आ गई आपके पास b. This is differentiable at 1, that means left hand derivative at 1 is equal to right hand derivative at 1, which gives you b is equal to 2 into 1 plus 3 is equal to 5. Now we got the value of b. Still we have to find the value of a. If this function is differentiable, this is continuous also. That means left hand limit at 1 is equal to right hand limit at 1. So left hand limit के लिए x की जगह पर 1 put किया तो it is 1 square plus 3 into 1 plus a is equal to b plus 2, but b was 5, so it is 4 plus a is equal to 5 plus 2, which gives you a is equal to 3. Okay, so another thing which is very important to this one and we have to use afterwards also, this is the algebra of derivatives. Other properties, most importantly, first one, if I'm writing in general, if f and g are two differentiable functions, then first one, f plus g is a differentiable in domain of f intersection domain of g. Second, f minus g, continuity में भी हमने ये लिखे थे, is differentiable in domain of f intersection domain of g. Third, f into g is differentiable in domain of f intersection domain of g. Fourth, f upon g is differentiable in domain of f intersection domain of g minus all those x for which gx is equal to 0. Second, if f and g are differentiable, then their composition is also differentiable in domain of g. So as we have taken f and g are continuous, then f plus g is continuous, f minus g is continuous, f into g is continuous, f upon g is continuous in common domain except those x for which denominator is equal to 0. Composition was also continuous. Similarly, if f and g are differentiable function, then their sum is differentiable in the common domain, difference is differentiable in the common domain, product is differentiable in the common domain, and quotient is differentiable in the common domain, except those points for which gx is equal to 0. Also, the composition of two differentiable functions is differentiable. Now, another thing which we have to use afterwards, that is differentiability implies continuity. That means if a function is differentiable, that is also continuous. But converse is not true. That is continuous function need not be differentiable. A continuous function may be differential, may not be differentiable, but in general एक continuous function जो होता है जरूरी नहीं है कि differentiable हो. जैसा कि हमने एग्जांपल देखा था मॉडुलस फंक्शन का, तो हम इस वीडियो में इतना ही रख रहे हैं. We'll be having Rolle's theorem and mean value theorem and other part of differentiability in the preceding videos. Thank you for this.